आ गए लाइव. So guys, फिर से we are going to start study session, right? Let's first open the clock. I will set it to 1.5. Let's start it. Let's close it now. Let's open the files I need. So we're studying matter surrounding us pure. This is not completed, right? So we last study is here. Now today continuing the chapter. So let's go. So physical and chemical changes, right? So what is a physical change and what is chemical change? They are asked if what do you understand by that? So if I tell you in simple way, physical and chemical change is basically, physical change means this is a rubber ball. If you press it hard enough, if you press the ball hard enough, the ball becomes smaller. This is called, what is this called? So this is called physical change. It's called physical change. Now if I am telling you, now if it's physical change, right? Now I'm giving you example like a iron nail. This is the iron nail. In this iron nail, if you this iron nail, you throw it outside, and after rainfall and other things, sorry for the inconvenience. Now, so what I'm saying this is a iron nail, right? So if you throw it outside and just throw it outside, after so many, if you throw it outside, or you take it and dip in water and throw it outside, and after few days you will see that this iron nail gets rusting all over his body, rusting and rusting, and you can see the iron nail from color also changes. So that's we called chemical change. So chemical, in physical change, the size and shape will change of a object, but in chemical change, the object will change, not the size or something. Understanding it? Chemical change is basically, it not size or it will not change, but in chemical change, so what it says here, it says that's physical and previous. So they didn't give examples, right? So in this previous chapter we have learned about a few physical properties of matter, the properties that can observe and specified like color, hardness, rigidity, fluidity, The density, melting point, boiling point, etc. are the physical properties. The interconversion of states is a physical. So interconversion of states is a physical change because these changes occur without a change in composition and no change in the chemical nature of the substance. Although although ice, water and water vapor all look different and display different physical but different physical properties but different display different physical properties, they are chemically the same. Both water and cooking oil are liquid, but their chemical characteristics are different. They differ in odor and inflammability. So we know that oil burns in air, whereas water extinguishes fire. It is the chemical property of oil that makes it different from water. Burning is a chemical change. During this process, one substance reacts with another to undergo a change in chemical composition. So, chemical change brings change in the chemical properties of matter and we get new substances. Got it? So, a chemical change is also called a chemical reaction. During burning of a candle, both physical and chemical changes take place. Can you distinguish these? So, So these are the questions or classify the following chemical or physical changes. Okay, classify. Cutting of trees, it's a physical. Melting of butter in a pan, it's a chemical. Rusting of almira, rusting of chemical. Boiling of water to form steam, chemical. Passing of electric current, passing of electric current through water and the water breaking down into hydrogen oxygen is a chemical. Dissolving common salt in water, chemical. Making a salad with raw fruits, making a fruit salad with raw fruits and burning a paper and wood. So making the fruit salad with raw fruits, it's a physical. Burning of paper and wood, it's a chemical. Try segregating the things around you as pure substances or mixtures. So what are the types of pure substances? So one of the basic of their chemical composition, substances can अरे call पे hello 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 hello. Sorry for ignorance, I got a call, that's why I Wait a minute, yes, I'm coming now. guys, sorry. I come back. Sorry. Sorry for the inconvenience. Sorry. Extremely sorry. Now I'll continue. Now I will continue. Sorry. So where are we? We're in what types of pure substance? So on the basis of their chemical composition, substances can be classified either as elements. On the basis of their chemical composition, substances can be classified either as elements or compounds. So substances either, so pure substances, they are saying pure substances has two types. One is elements and another is compounds. So elements. So Robert Boyle was the first scientist to use the term element in 1961. Who used the first? Robert Boyle was the first scientist to use the term element in 1661, and Antonio Laurent Lavoisier, 1743 to 1940, a French chemist, was the first to establish an experimentally useful definition of an element. So he defined an element as a basic form of matter that cannot be broken down into simpler substance by chemical reaction. So elements can be normally divided into metals, non-metals and metalloids. So metals usually show some of all of the following properties. Metals usually show some or all of the following properties. They have a lustrous sign. So they have a lustrous sign. They have a basically they are it's complicating. NCERT is complicated. Means they are how NCERT is a complicated book. They only if they give simple words and simple definitions, then student don't have the hard time to understand. But they are not doing that. So elements can be normal. Say they here see they have a lustre. Why they use lustre? They can use sign, right? They also said that elements have a sign. Shining sulfur. They have silvery gray or golden yellow color. Okay. They conduct heat and electricity. Okay. They are ductile, can be drawn into wires. They are malleable, can be hammered into thin sheets. And they are sonorous, make a ringing sound when hit. Examples of metals are gold, silver, copper, iron, sodium, potassium, etc. Examples of metals are gold, silver, copper, iron, sodium, potassium, etc. Mercury is the only metal that is required at room temperature. So mercury is the only metal that is liquid at room temperature. So non-metals usually show some or all of the following properties. They display a variety of colors. They are poor conductors of heat and electricity. They are not lustrous, sonorous, or malleable. Examples of nonmetals. Examples of nonmetals are hydrogen. Examples of nonmetals are hydrogen, oxygen, iodine, carbon, coal, coke, bromine. Examples of nonmetals are hydrogen, oxygen, iodine, coal, coke, and bromine, chlorine, etc. So some elements have intermediate properties. Between those of metals and non-metals. Intermediate properties means both. They show both functions like metals and non-metals. That's called intermediate properties. So properties, metals and nonmetals. So they are called metalloids. Examples are boron, silicon, germanium. These are the examples of metalloids. Metalloids means those substances or those elements who show both properties, metals and non-metals. Examples are boron, silicon, germanium. So the number of elements known at present are more than 100, right? So 92 elements are naturally occurring and the rest are man-made. So majority of the elements are solid. The number of elements known at present are more than 100. 92 elements are naturally occurring and the rest are man-made. Rest are man-made. More than 100 means 118 elements are present. 92 are naturally occurring and others are man-made. The majority of the elements are solid. 11 elements are in gaseous state. Majority of elements are solid. 11 elements are in gaseous state at room temperature. 2 elements are liquid at room temperature, mercury and bromine, and elements like gallium and cesium, become liquid at room temperature, slightly above room temperature 303 K. Okay. So now compounds. So what is compounds? So a compound is a substance composed of two or more elements chemically combined with one another in a fixed proportion. So what do we get when two or more elements are combined? So what do we get when two or more elements are combined? When two or more elements are combined. So a compound is substance composed of two or more elements. Composed of two or more chemically combined with one another fixed in a fixed proportion. So what happened on combine? So first divide the class into two groups, give 5 gram iron fillings and 3 gram of sulfur powder in a china dish to both the groups. So group 1, mix and crush iron fillings and sulfur powder. Group 2, sulfur powder. Group 2, mix and crush iron fillings and sulfur powder. Heat this mixture strongly. Heat this mixture strongly. Heat this mixture strongly. Heat this mixture strongly. So heat this mixture. Where is it? So heat this mixture strongly till red hot. Remove from flame and let the mixture cool. So group 1 and 2. Check the magnetism in the material of. Bring a magnet near the material and check if the material is attracted towards the magnet. So compare the texture and color of the material obtained by the groups and carbon disulfide to one part of the material obtained. Stir well and filter. So add dilute sulfuric acid or dilute hydrochloric acid to the other part of the material obtained. Note, teacher supervision is necessary for this activity. Perform all the above steps with both the elements, iron and sulfur separately. Now answer. Did the material obtained by the two groups look the same? Which group has obtained a material with magnetic properties? Can we separate the components of the material obtained? Okay. On adding dilute sulfuric acid and dilute hydrochloric acid. Sulfuric acid is H2SO4 and dilute hydrochloric acid HCl acid. Did both the groups obtain a gas? Did the gas in both the cases smell the same or different? So the gas obtained by group 1 is hydrogen. It is colorless, odorless and combustible. It is not advised to do the combustion test for hydrogen in the class. The gas obtained by group 2 is hydrogen sulfide. It is a colorless gas with the smell of rotten eggs. You must have observed that you must have observed that the products obtained by both the groups show different properties through the starting materials were the same. Group 1 has carried out activity. Group 1 has carried out the activity involving involving a physical change whereas in case of group 2 a chemical reaction has taken place. The material obtained by group 1 is a mixture of two substances. The substances given are the elements iron and sulfur. The properties of the mixture are the same as that of its constituents. Table 2.2, mixtures and compounds. Mixtures, so here is a difference, they are given mixtures and compounds. So first, so elements and or compounds just mix together to form a mixture and no new compound is formed. Elements and compounds just mix together to form a mixture and no new compound is formed. Now compounds, elements react to form new compounds. Here elements react to form new compounds. A mixture has a variable composition. Where it go? So a mixture has a variable composition. Second, variable composition, a mixture is variable means different composition. It is not fixed. In a mixture, the composition is not fixed. The composition of each new substance is always fixed. Here is fixed, here is not fixed. 3. A mixture shown the properties of the constituent substances. A mixture shows the properties of the constituent substances. Okay, means a mixture shows the properties of the constituent substances means, and the new substance has totally different properties. So they are saying constituent substance. These words are fucking, sorry to say, but these words are fucking different. Why they use this type of words? They use simple words. Don't know about this. Constituents. Constituents means what's happening, bro? Constituents. भेड़ में तन्हाई में। What the fuck? What the fuck? Impacto. Oh shit. Let's leave it. So constituent substance, the new substance has totally different properties. The constituents can be separated fairly easily by physical methods. So the constituents can be separated. The constituent can be separated fairly easily by physical methods. The constituents can be separated only by chemical or electrochemical reaction. So the material obtained by group 2 is a compound. The compound, and on heating the two elements strongly, we get a compound which has totally different properties compared to the combining elements. The composition of a compound is the same throughout. We can also observe The composition of a compound is the same throughout. We can also observe that the texture and the color of the compound are the same throughout. Thus, we can summarize the physical and chemical nature of the matter in the following graphical organizers. So now they are giving a structure. So see, so first matter, then matter have two different types like pure substance and mixtures, solid, liquid, gas, matters. So pure substance also have two elements and compounds, and mixture also have homogeneous and heterogeneous mixtures. So in homogeneous already we learned already about that, right? So you have to just read it. Example, copper hydrogen elements, for example water, methane, sugar, salt. And here homogeneous, for example sugar in water, salt in water. And heterogeneous, for example sand, water, salt. So what you have learned, a mixture contains more than one substance, element and or compound mixed any proportion. Mixture contains more than one substance, element and or compound mixed in any proportion. Mixtures can be separated. Mixture can be separated into pure substances using appropriate separation techniques. A solution is a homogeneous. A solution is a homogeneous mixture or two or more substances. The major component of a solution is called solvent, and the minor is solute. Solvent is the which present in larger amount, and solute is the which present in smaller amount. So now the concentration of a solution is the amount of solute present per unit volume or per unit mass of the solution. The concentration of a solution is the amount of solute present per unit volume. The concentration of a solution is the amount of solute present per unit volume or per unit mass of the solution. Materials that are insoluble in a solvent and have particles that are visible to naked eyes form a suspension. A suspension is a heterogeneous mixture. Okay, we also learned about suspension, right? We can see the visible to naked eyes. Now colloids. Now here is colloids. Colloids are the heterogeneous mixture in which particle size is too small to be seen with naked eyes but is big enough to scatter light. Colloids are useful in industry and daily life. The particles are called the dispersed phase, and the medium in which they are distributed is called the dispersion medium. So pure substances can be elements or compounds. An element is a form of matter that cannot be broken down by chemical reactions into simpler substances. A compound is a substance composed of two or more different types of elements, right? So chemically combined in a fixed proportion. Always chemically combined in a fixed proportion, or element, or if I say compound, always fixed proportion. Compounds. Now, properties of a compound are different from its constituents. Yes, properties of compound are different from its constituents elements. Like if I give you example, here says property of compounds are different from its constituents elements. Like this H2O. Let's say, sorry, 2H2O and 2H2 plus O2. Now you can see these two H2O plus O2, they are making this water. But see, here is oxygen and hydrogen. They both help to help to help to help to ignite fire. But water do the opposite. Water help to put out the fire. So these are they are talking about. Constituents are elements are different from its compounds. So whereas a mixture shows the properties of its constituent elements or compounds, whereas a mixture shows the properties of its constituting elements or compounds. Now they give some exercises here. Oh, which separation technique will apply for separation of the following? Which separation technique will which separation techniques will you apply for separation of the following? Okay. Sodium chloride from its solution in water. Sodium chloride NaCl, right? Sodium chloride from its solution in water. Separate. If we want to separate NaCl from water, then we have to heat them up. Heat them up and until the water evaporates. After the water evaporates, the NaCl present in that. Second one, ammonium chloride from a mixture containing sodium chloride and ammonium chloride. So ammonium chloride from a mixture containing sodium chloride, okay, and ammonium chloride. Small pieces of metal in engine oil of a car. So how do we do that? Let's ask. Why is it present here? I want new. Today we dive into this. Dive into this. So they giving the answer or what? The method used here is sublimation. When the mixture is heated, ammonium chloride sublimates turning into vapor. Sodium chloride does not sublime, it remains as a solid residue. So here we use also the same trick, heating them up, sublimation, because the ammonium chloride will evaporate and the NaCl or sodium chloride will not evaporate and stay. This is how we separate small piece of metal in engine oil of a car. Oil of a car. So we just small pieces of metal in the engine oil of a car. We just have to filter it out. That's all. Different pigments from an extract of flower petals. What? Different pigments from an extract of flower petals. Oh, what are you saying? Different pigments. Different pigments from an extract of flower petals is part of an exercise in your class and separate matter around us. Okay. Separation of, since pigments are soluble but have different affinities for solvents and surfaces, they can be separated using chromatography. So they can be extracted by chromatography. These techniques relies on the fact that different substances move at different speeds when carried by a solvent across a medium like filter paper. Crush flower petals and prepare a extract in suitable solvent like alcohol or water. Pick a small spot of exact near the base of strip or filter paper. Dip the paper into a solvent without immersing the spot directly as the solvent rises through the paper. Pigments travel upward at different rates. They separate into distinct colored bands at different heights. So first crush flowers petals and prepare an extract in a suitable solvent like alcohol or water. So first crush them and put them in water or alcohol. After that, dip the paper into a solvent without immersing the spot directly. After that, after that, dip the paper into a solvent. Okay, dip the paper into a solvent without immersing the spot directly. Okay, so dip the paper in that solution. As the solvent rises through the paper, okay, as the solvent rises through paper, so the paper absorbing the what it called, absorbing the solution, right, wet the paper. So here it's saying as the solvent rises through the paper, the pigments travel upward. Okay, so in that paper, the pigments also traveling through the paper, so they are rising above, rising rises through the paper, pigments travel upward at different rates, the separate into distinct colored, they separate into distinct colored bands at different heights. Okay, so that's how they do it. Okay, butter from curd, butter from curd, butter from curd, it's a physical change. How we differentiate it? Butter from curd, so if the curd is, I also have to ask this. Butter from curd, curd contains goluble separate from, the method used here is centrifugation. This technique separates components of a mixture based on their density by spinning it at high speed. How? Place the curd in a centrifuge machine or churn it manually, which is the traditional method. Oh, when spoon rapidly and denser particles like proteins and water stay at the bottom, the lighter fat golubles butter separate out and collect at the top. Okay, so centrifugation, the technique separates components of a mixture based on their density by spinning it at high speed. So have you seen that machine, right? When that help to mix things up, right? Like a gun, that kitchen thing. If you take the curd in a bowl and that use it, that centrifugation technique, or what is centrifugation, is spinning it high speed component with centrifuge machine. If you press it in high speed, the butter and curd will separate from each other. Oil from water is basically oil from water. How you do it? Oil from water, I can say. Oil from water, how you do it? Same thing, I guess. Oils also, the method used here is separating funnel technique, which works on the basis of difference in densities of immiscible liquids. The method used here is separating funnel technique. Method here used in separating funnel technique. Separating funnel. Separating funnel, centrifugation technique. Extract flowers is a paper. That's paper called pigmentation, chromatography. This is called chromatography. Ammonia also learned chromatography, centrifugation technique. And butter, it's a centrifugation technique, and it's a chromatography. And oil engine, it's a just filtering. And oil from water funnel. So what funnel? I For pour boil water into make separating funnel. Allow the mixture to settle oil from upper layer. Separating funnel. Tea leaves from tea. Just a filter. Iron pins from sand. Iron pins from sand. How can you do it? Here also we can use the filter. Big filters. And wheat grains from husk. Wheat grains from husk. How? Here also we can use a filter. Fine mud particles suspended in water. Fine mud particles suspended in water. Here you have to use, because here you don't know how to. How? How we can do it? This creates a homogeneous mixture. We know that, but mud particles are insoluble in water. Okay, when mixed, they remain dispersed throughout the liquid. Do not dissolve. This creates a heterogeneous mixture. Okay, I know that. The particles are large enough to be seen with naked eyes. The scattered light. Okay, they are unstable. If left undistributed, the mud particles settle down at the bottom. They can be separated by filtration. Yeah, this is also filtration. So now write the steps you would use for making tea. Use the word solution, solvent. Okay, you can do that. It's a simple one, right? So we're leaving it. So Pragya tested the solubility of three different substances at different temperature and collected the data as given below. Results are given in the following table as grams of substances dissolved in 100 grams of water to form a. Results are given in the following table as grams of substance dissolved in 100 grams of water to form a saturated solution. To form a saturated solution. Bro, to form a saturated solution. So substance dissolved temperature in K to 83 to 93. ना जाने तो मेरे इरादे ले जाऊंगा से शुरू के Let's go. So these are the given are, so she tested, right? So these are the given results. So temperature in Kelvin, substance dissolved. So 283 Kelvin, potassium nitrate 21. solubility in temperature in Kelvin. Okay. So collected data is given below. So results are given in the following table as grams of substance dissolve in 100 grams of water to form a saturated solution. Pragya tested the solubility of three different substances. Okay. Pragya tested solubility of three different substances at different temperatures and collected the data as given below. So results are given in the following table. Results are given in the following table. So results are given in the following table. Results are given. The results, the substance at different temperature and collected data is given below. So the results are given in the following table as grams of substance dissolved in 100 grams of water to form a saturated solution. Okay. So substance dissolved. Potassium nitrate is 21 gram. Okay. Sodium chloride 36. Potassium chloride, ammonium chloride. Sorry, I didn't understand what the question says. It says Pragya tested the solubility, okay, of three different substances. Three different substances at different temperatures and collected the data as given below. Solubility of three different, okay. Solubility of different substances at different temperatures. So solubility of potassium nitrate at 283 Kelvin 21. Solubility of sodium chloride at 283 36. Potassium chloride 35, ammonium chloride 24. Now 293, temperature at 293, potassium nitrate 32, sodium nitrate 36, potassium chloride 35 and ammonium chloride 37. Okay. So temperature gives 313, 62 potassium nitrate, 36 sodium chloride and potassium chloride 40. So ammonium chloride is 41. Temperature in K3 333. Potassium nitrate here is 106 and sodium chloride is 37, potassium chloride 46, ammonium chloride is 55. Now potassium nitrate is 167, sodium chloride is 37, potassium chloride is 54 and ammonium chloride is 66 in 353 Kelvin. So what mass of potassium nitrate would be needed to produce a saturated solution of potassium nitrate in a 50 grams of water at 313 Kelvin? What mass of potassium nitrate would be needed to what mass of potassium nitrate would be needed to produce a saturated solution of potassium nitrate in 50 grams of water? 50 grams of water, what mass of potassium nitrate would be needed? 330. Okay, potassium nitrate given. So potassium nitrate is 21, right? What mass of, and 50 grams, so 50 grams of water, 50 and potassium 21, 71 into 100. If I calculator, and 21 divided by 71 into 100, how much? 29.57. 29.57. Now let's check it out. How? 62. Oh, sorry, I wrong. 62 is given, 63, I take the wrong. So it will be 62 divided by 62 plus 50. 50, 60, 110. 112 divided by 112 into 100, 55.35. So the answer will be 55.35. 55.35. But here says 31 gram. What did I do the mistake? So at 33 Kelvin, substance nitrate 32 gram per 100 gram. Okay. So per 100 gram is 62 gram. 62 gram per 100 gram of water from the table provided in textbook. So the question asks at 50 gram of water, not 100 gram. So if 50 gram of water dissolves 62 gram of potassium nitrate, then 50 gram of water will dissolve. So here I did the mistake. So they ask about 50 grams of water, not 100 grams of water. 62 gram per, here also they say they 100 dissolved in 100 grams of water, right? But here say 50 grams. So that's why here I also did a mistake. It will be 50. So if I open the calculator, I cannot change it, right? So 62 divided by, also why it is 100, why is not 112? The questions asks about 50 gram of water, not 100 gram. If 100 gram of water dissolves 62 gram of potassium nitrate, then 50 gram of water will dissolve. So at 13 Kelvin of solubility, potassium nitrate is 62 gram per 100 gram of water, right? From the provided tables. Now they are asking of 50 gram of water. 50 gram of water. Oh, it's simple. Why use that? You can 62, you can say 31 as quickly as it. 62 by 100 into 50, right? 5 to the 2, 3, 2, 1. 31 is the right. It's simple. Why I'm making it so complicated? It's just simple. Now, Pagya makes a saturated solution of potassium chloride in water at 353 Kelvin and leaves the solution to cool at temperature. Cool room temperature. What should the observe as the solution cools? Explain. Find the solubility of each 23 gram which salts at the highest solubility at the temperature. Oh, they are giving some good questions. So Pagya makes a saturated solution of potassium chloride in water at 353 Kelvin and leaves the solution to cool at room temperature. What would she observe as the solution cools? Pagya makes saturated solution potassium chloride KCl in water at 53 Kelvin and leaves the solution to the cool room temperature. What would she observe as the solution cools? So she will not observe many things as much. She will observe that the KCl saturation solution contains maximum amount of solute can dissolve when bleed. So the effect of cooling, when the solution is cooled to the room temperature, solubility of potassium chloride decreases. This means the solution can no longer hold as much solute as it did at higher temperature. So observation, as the solution cools, the excess potassium chloride will separate out as a crystals. Pragya observes solid potassium chloride setting a crystals from the solution. Okay. So when it will get cooled down, the potassium chloride will no longer will separate out as a crystal. This means solution can no longer hold as much solute as it's possible, as much solute. So it will separate and become crystals. So find the solubility of each salt, 293 Kelvin. Which salt has the highest solubility at this temperature? 36. Find the solubility of each salt. Each salt. Find the solubility of each salt at 293 Kelvin. Which salt has the highest solubility? Which salt has the highest solubility at its temperature? At this temperature. Find the solubility of each salt at 293 Kelvin. Which which salt has the highest temperature, highest solubility at this temperature? Find the solubility of each salt at 293 Kelvin. Which salt has the highest solubility at this temperature? Find the solubility of each salt at 293 Kelvin. Which salt has the highest solubility at this temperature? Where did this come from? Find the solubility of each salt at 293 K. Which salt has the highest solubility at this temperature? Which salt? Highest solubility. See crystals of potassium chloride forming as the solution cools because the solubility of KCl decreases at lower temperature. What is the what about than this? Okay, सबका बोला है 293. They are asking for all. Potassium nitrate 332 gram per 100 gram water. 36 gram. So this is the compares values. So in 293, 32 gram of water in 100 gram. First 32 gram, 36 gram of 100 gram, 35 gram of 100 gram, and 37 gram of 100 gram. So the compare values. So the solubility of each solid is KNO332. So the ammonium chloride has the highest solubility. What is the effect of change temperature on the solubility of salt? What is the effect? What is the effect of change? What is the effect of change of temperature on the solubility of a salt? What is the effect of change? Now, what is the effect of change of temperature on the solubility of a salt? So, the solubility of most salts increases with rise in temperature. This means that at highest temperature, more salt can dissolve in the same amount of water. Examples from the table. Potassium nitrate shows a sharp increase in solubility as temperature rises at 293 Kelvin, about 32 gram. Rising temperature generally increase solubility of salts, okay, but the extent of increase varies from salt to salt. But the extent of increase varies from salt to salt. Like the effect of temperature and solubility depends on the salt. For most salt, solubility increases with temperature. For some salt like NaCl, solubility is almost unaffected. Okay, that's what is the effect of change of temperature on the solubility of salt. So when a saturated solution, so when saturated solution prepared at a higher temperature is cooled, the excess salt that can no longer remain dissolved will crystallize out. This is why crystallization is used as a purification method. Okay, so conclusion: the effect of temperature on solubility depends on the salt. For most salts, solubility increases with temperature. For some salts like NaCl, solubility are almost unaffected. Explain the following giving examples. Explain the following giving examples. Saturated solution, pure substances, colloid suspension. Explain the following giving examples. So colloid also we know that 1 nm to scatter, they show the scattering light effect. They also between raised to 1 nm to 1000 nm. We cannot see them in naked eyes. And second one is the suspension as the mud in water, chalk in water. We can see with our naked eyes. Also their size is above 1000 nm. Now saturated solution and pure substance. Pure substance are the elements. Pure substance are the elements like iron, gold, silver. Also in pure substance there are two types. One is compounds and one is elements. Or also pure substance are the pure substance has many. Pure substance are the substances are the substances. Pure substance, pure. Saturated solutions means and pure substance, right? Saturated and pure. So a saturated solution is the one that contains the maximum amount of solute that can dissolve in a solvent at a given temperature. What it says a saturated solution is one that contains the a saturated solution one that contains the maximum amount of solute. Maximum amount of solute means NaCl. Water NaCl, NaCl is the solute, right? So Na maximum holds one that contains or holds the maximum amount of solute that can dissolve in a solvent. That can dissolve in solvent at a given temperature, like in water. Key idea: if add more solute beyond this point, it will not dissolve. A pure substance is made up of only one. Okay, a pure substance made up of only one type of particles or atoms, and it is a fixed composition and a fixed composition. Now, classify it following as a homogeneous or heterogeneous mixture. Soda water, wood, air, soil, vinegar, filter tea. Each following homogeneous or heterogeneous. So, soda water is a soda water is a homogeneous. Wood hetero, air homo, soil hetero, vinegar homo, filtered tea hetero. So how would you confirm that a colorless liquid given to you is a pure water? How would you confirm that a colorless liquid given to you is pure water? How would you confirm? Gari sari sari re gari sani pa. So boiling point, so pure water has a fixed boiling point at 373 K or 100 degrees Celsius at 1 atmospheric pressure. If the liquid boils exactly at this temperature, it indicates purity. Okay, so we will use the giving heat to them, giving heat to the heat to the pure water or colorless liquid. if if its boiling point at 373 K or 100 degrees C at 100 degrees C at 1 atmospheric pressure. If the liquid boils exactly at this temperature, if the liquid boils exactly at this temperature, it indicates purity. Now, which of the following materials is fall in this category of a pure substance? I will mark it out. Pure substance category fall in pure substance, right? Iron, mercury, Ice is no, ice is a pure substance or not? Ice is not pure substance. Yeah, ice, not a mixture, bro. Air is a mixture, wood is a mixture, breakage of mercury, no, calcium oxide. Calcium oxide pure, not pure, it's a also hydrochloric acid, HCl. It's a mixture, right? Hydrochloric acid, not a pure substance. So it's not hydrochloric and these two both. It's a compound, I guess, pure substance, right? Hydrochloric and CaO also compound. These two are compounds, so these two are pure substance. So identify the solution among the following mixtures. Identify the solution among the following mixtures. Solution means solutions. Okay, soil solution is soda water. Sea water also a solution. Air, coal, soil. No. Which of the following will show Tyndall effect? Milk, copper sulfate solution, starch solution also show. Copper sulfate solution not. Classify the following into elements, compounds, and mixtures. Just check it out. Salt, copper, milk, and starch. Yes, I am right. So now classify the following into elements and compound and mixtures. Classify the following into classify the flaw classify the following. So classify the following into elements, compounds, and mixtures. Classify the following into elements, compounds, and mixtures. Okay. So sodium is a element, soil is a mixture, sugar solution is a mixture, silver is a element, calcium carbonate is a compound, tin is a element, silicon element, coal is a mixture, air is a mixture, soap is a mixture, methane is a compound, carbon dioxide compound, blood is a mixture. Which of the following are chemical changes? Growth of a plant. Growth of a plant is physical change, not chemical. Rusting iron is chemical changes. Mixing of iron, filling and sand. Mixing of no. Cooking of food, chemical. Digestion, chemical. Freezing water. Burning of candle, chemical. Cooking of food is chemical changes. Yes. So chapter finished. So guys, this chapter also finished. Now in next stream we'll learn about next chapter. So I will end the stream here. So thank you for the watching stream. If you like the stream, so I'm studying basically. If you like the stream and like the stream, then you can subscribe and like and stay tuned for the next, and also click the bell icon, because when I'll be streaming in next stream, then you will get a notification about it.